Hello class and welcome to lesson 6.3a, transformations of sinusoidal functions. And the A part means today we're going to be using the technology, which is a graphing calculator, to help us explore different transformations. This is going to be similar to past units where, ladies and gentlemen, we're going to take a look at how the letters A, K, D, and C affect the transformations of our base functions. Last class we learned we had two base functions. One, y equals sine x. Okay, and just remember a quick sketch. Sine x starts at the origin, goes up to its maximum, goes back to its axis, minimum, and then back to its axis. Whereas the second base function, y equals cos x, okay, when we graph that, it starts at its maximum, goes to the axis, down to its minimum, back up to its axis, and then back to its maximum. Okay, and again, that just shows one rotation, ladies and gentlemen. Remember that these are continuous functions, so they would continue on. So if I had arrows on each of them, again, that's just showing one cycle of the parent function. So what we're going to do is perform transformations based on either of these two parent functions, which is the sine x curve and the cos x curve, and we're going to take a look at what letters affect each graph. And this is the heart, or this is the nuts and bolts of what sinusoidal functions is, folks. Remember, a sinusoidal function is a transformation from either a sine x curve or a cos x curve. All right, and that's what makes this a sinusoidal function. All right, so grab your graphing calculators, guys, or use an online graphing app. Okay, the biggest thing here, folks, is to change your mode from radians to degrees, because in the past we've been dealing with our x-axis as values, but now our x-axis is going to be based on degrees. Okay, so that's going to be the new thing. So make sure that your x-axis is on degrees. How do you do that? Go to mode, change it from radian to degree. Another thing we want to do is change our window so that we've got an appropriate scale to help us with graphing. Now, I believe in your handout, ladies and gentlemen, the scale is already on the grid, so that would be helpful for you. And here we go. Let's get started. So for the first set, it says graph each set of functions and sketch the results. Well, what we're noticing, folks, is the trend is what happens from the first one. This is our base function, or one of our base functions, okay? And when we look at our second one, we notice that there's a letter out in front. Hopefully you remember the letter out in front represents A. So this tells us that A equals 3. If we back up to our base function, A equals 1. If I continue on to my third equation here, sorry, I've got a cough, just give me a second. Sorry, guys. It's a little flu season right now. Anyway, looking at our third equation, guys, A equals 1/2. And at our last one, please be careful here. You got a negative sine x. So what does that mean? That means A equals -1. All right. So now we're going to graph these, ladies and gentlemen. And you can use the graphing calculator to get you started. But you should remember from the base function, it starts at its axis. It goes to a maximum, comes back down to its axis. Okay. Then goes to its minimum, and then goes back to its axis. So this shows one cycle, ladies and gentlemen, of the sine x curve, which is the base function. However, when we're doing functions, it's continual, so I want you to follow that pattern and keep going. So it's going to go to its, and I might draw your points first, maximum, axis, and then come down here for your minimum. Okay. And then draw arrows. We're going to do the same pattern. So if you're going the opposite direction from the origin, instead of going to my max first, I'm going to go minimum, axes, max, axes, minimum, axes. So what you're going to see, guys, is it's a repeating rhythmic pattern. Okay? So that's your sine x curve. Okay. In the past, you notice that A is a vertical stretch. So if we have A equals 3, Instead of going to a maximum of 1, we're going to stretch that 3 times. So instead of going 1, we're now going to be a maximum of 3. Likewise, for our minimums, instead of being at a minimum of -1, we're going to be at a minimum of -3. So we're going to start at our axis, go to our maximum, come back to our axis, and back to the minimum, back up to your axis. Again, that shows one cycle. However, we continue this as a repetition, and because it continues. So I'm just going to draw the dots in, and then I will draw the rest of my curve. Okay, so again, it takes some time to getting used to. I find the bigger the amplitude, which is what we're going to learn this is today, the easier it is for me to draw. So I enjoy drawing ones that have a little more curve like this. Okay, so continue. Again, you use a colored pencil crayon or marker. It'll help you. Okay, draw your arrows at both ends. So that's y equals 3 sine x. So we've stretched it 3 times. Okay, a is 1/2. So instead of going from my base function to 1, I'm going to go half the distance. Okay, so you'll notice that this is going to be a smaller, because instead of stretching it vertically, we are compressing it vertically. Okay. So when you draw this one, it's a little smaller, and I find this one's harder to draw because there's less curvature on it. You may enjoy it more, but for me personally, all right. So there's our third graph, ladies and gentlemen. Okay, put arrows on it. Let's take a look at our fourth one. Our fourth one is y equals -x. So remember, that means it reflects the x-axis. So instead of starting at my origin and going to my maximum, I'm actually going to go to my minimum because it reflects the x-axis. So basically, I'm doing the opposite patterning of what I had from my original base function. Okay, gang? So let me just put that in, and then we will draw our last graph for this section. Okay, so by the end of this today, you should hopefully get a nice smooth idea of how to draw these curves. All right, draw arrows at both ends. All right, so what we have just done investigation, hopefully we've been plugging the graphing calculator to check it. What we've done in this investigation is discussed what happens to A. So let's just recap or describe the transformations and the effect that we have on y equals a sine x. So first of all, if A is less than 0 or it's negative, don't forget, guys, that reflects the x-axis. Okay. If the absolute value of A is greater than 1, we know that that's a vertical stretch. By a factor of absolute value of A. Okay, remember the absolute value comes into play here, folks, because if it's negative, it reflects. The rest is going to just going to tell us how far we are going to go from the axis. If A happens to be less than 1, folks, we have what's called a vertical compression. Again, by a factor of absolute value of A. Okay. Now, one thing that we're going to tie in that's different is that this plays a key role in what we've discussed so far in new terminology for sinusoidal functions. Hopefully, you've realized this connection, and I want you to make sure you've got this down pat, that the absolute value of A actually equals the amplitude. Okay. And if you're changing the amplitude, i.e. the maximum and the minimum, how far up you go and how far down you go, just remember that that changes the range. As you increase the amplitude, you increase the range, right? All right, let's take a look at a second example here. Notice that our base function is going to be cos x. So we're going to start with a different parent function, okay? And then we have, looking at the trend here, for the first one, we've got just the parent function cos x. For the second one, we notice that we have cos theta minus 3. Okay, so we got a -3 thing happening at the end. And in case you forget, folks, that's the c. So in this case, c equals -3. Okay, so to back up to the first one, c equals 0. Okay, that means we're not shifting up or down. Whereas in our third one, ladies and gentlemen, we've got cos x plus 2. So that means we're going up 2 because c equals positive 2, or c equals 2. Okay? So we're going to start by drawing our base function. Okay? If we're not traveling up 2, then the equation of axis stays the same. So remember, what's different about the cos x is we start at our maximum, we go to our axis, we go to our minimum, axis, and maximum. Again, that creates one cycle, which we would call the period. So the period of time it takes to create one cycle is 360 degrees. However, we continue with that same pattern, okay, because it's a continuous function. Okay, so let me just continue that on. And again, you're going to notice the same thing. You're going max, axis, min, axis, max, okay? All right, so there is our second base or parent function, cos x. Okay, and hopefully we reviewed the properties of that last class. Okay, now we're going to take a look at our second example. What we're going to do is it says we're taking cos x, so this parent function we've got here, and it says we're going to shift it down 3. So if we're shifting it down 3, that means we have to change the equation of axis. So instead of the equation of axis in the parent function being at 0, it's now going to be at -3. So I'm going to get you to draw a dotted line in the same color that you're going to draw that. Okay? And that's going to be our axis for the second graph. Okay, we're still going to start at our maximum, so 1 away from that. We're then going to hit our axis, go down 1, hit our axis, go up 1, hit our axis, go down 1, and come back and eventually hit our axis. So same patterning, guys, except it's been dropped 3 or lowered by 3. Okay, so I always tend to draw the equation of axis in to help me to make sure that I keep my symmetry going. Okay, so let's draw that. Okay, so that is our second graph. So notice this is just a vertical translation down from the parent function. Likewise, what should we predict is going to happen for the last graph here? Y equals cos x plus 2. We're going to shift it up 2. So to start with, I notice, hey, my equation of axis is not going to be at y equals 0. It's going to be at y equals 2. So I'm going to draw my axis, ladies and gentlemen. Remember that I've got to start at my maximum, go to my axis, go to my minimum, to my axis, to my maximum, to my axis, to my minimum, and back to my axis. Okay, same patterning on the other side. Axis, min, oops. See, you got to be careful here with your spacing. I missed that one, so fix that up. Axis minimum, that's better. Axis maximum, axis minimum, and axis would be over here coming up. So And ladies and gentlemen, you'll see that if you are interested in body art or tattoos, that many different cool band type style tattoos are formed from sinusoidal or periodic functions like we're dealing with in this unit. All right, so let's make a summary here on what happens when we have the C value, okay? So hopefully you've got this written down, that the properties for y equals cos x plus c. Just remember, if the c is greater than 0, we know that it goes, you're going to translate up. Okay. If c is less than 0, you're going to translate down. Okay. And the important thing I want to tell you guys is that we should learn that what has changed every time we have a shift either up and down, it's the equation of axis. So now we've got a new thing here, guys, that the equation of axis is y equals c. Make sure you know that. That's a new piece of the puzzle that we're going to put in here. And if we're shifting the axis up and down, I want you to also know that this helps to change the range. So the range changes from this as well. Okay. All right, let's keep going, folks. So I've already discovered the A and the C. Now let's take a look at a harder one, the K. Okay, so on the next page, you're going to find out that we're dealing with the letter K. The K is right in front or directly in front of the X. So we're going back to our original parent function, y equals sine x, just because I call it original because we used it in example A. Okay, and notice that K equals 1. In my second example, K equals 2. Okay. In my third example here, K equals 1/3. Okay. And in my last example, K equals -1. Okay. So what I want you to remember, guys, we learned last day that the period is 360 degrees. So when K equals 1, the period is 360 degrees. What I want you to remember or note, ladies and gentlemen, is that K is what we call a horizontal. You can either compress it or you can stretch it. So it's going to change the period, okay, by whatever factor we stretch it or compress it. So the new thing I want you to learn, folks, is that 360 degrees divided by the absolute value of K is going to equal the period. Okay, remember that when we take a look at doing factors of K, it's always 1 over K, right? 1 over the absolute value of K, we're taking the factor. So when you take a look at the second example, K equals 2. So that means the period is going to equal 360 degrees divided by 2, which equals 180 degrees. Okay, so what does that tell us? That means that we're pushing in, okay, or compressing in, so that instead of having 360 degrees for one cycle, we're going to have it in only 180. So within the regular 360, you're going to see 2 of our sine curves there. Likewise, when I have a 1/3, when you try to figure out that period, again, period equals 360 degrees divided by 1/3. You got to invert and multiply that. That's going to equal 1,080 degrees. That's even longer. So that's going to be a stretch by 3 times. So right, instead of 360 degrees, we're going to stretch that 3 more times, which is going to be 1,080. Okay. And when we take a look at K being -1, okay, the absolute value of K is still 1, so my period is still going to equal 360 degrees, but it's got to remember, guys, it reflects the y-axis. Okay? All right. So just because I have this written down, I'll see if I can, we're going to summarize this. I just wanted to erase this part here, ladies and gentlemen, so that I can fit my graphs in because I forgot I still to draw them. So I will put that down maybe on the side here, or we're going to summarize it in the middle, in the midpoint, but here I should be safe. So let's just put that down. I'll just rewrite it here. So period equals 360 degrees divided by the absolute value of K. Because that's going to be your stretch or compression in the horizontal, which affects your period. All right, so let's draw some of these. Okay, remember hopefully from the first example, for sine x, you start at your axis, you go to your max, axis, min, axis. Keep going. Max, axis, and min. Do it the other side. All right, so when we go to draw this, put some arrows on them. Okay, so there's our parent function, sine x. Okay, now here is the tricky part. What we need to realize is that instead of taking, notice our parent function here, ladies and gentlemen, it was completed within 360 degrees. What we need to have instead, in this case, for the second one, when I'm choosing red, I'm going to start here, but I need to complete my revolution at 180. Halfway through, I'm going to have to get to my axis, back again. So I'm going to reach my maximum halfway through. So basically at 45 degrees, I'm going to have to reach my maximum to make it symmetrical. And then I'm going to come back down, and halfway through there, come back up. So that is one cycle of it. Okay? We've got to keep going and make more. So just wanted to show you guys that this K factor might make a little bit more sense for you now. You know how it's 1 over the absolute value of K? Okay, this is actually what we call a horizontal compression because we're pushing it closer. So instead of having 1, like my parent function, 1 cycle within 360, we've got 2. That's why K equals 2. So if you're wondering why in the past we did the 1 over the absolute value of K, here is a valid reason to show you why. Okay, and then we're going to continue to try to keep this pattern going. Okay, and create more graphs. Here we go. Isn't it fun drawing, guys? I wish I was a little bit more artistic. I know some of you guys are much more artistic than I am. All right, so there's your second example. And again, ideally it'd be great to have curvier lines than what I'm doing, but that's okay. I'm not going to dock your marks if they're not completely curved. Okay, let's take a look at the third one. The third one says, hey, we're going to notice that K is 1/3. That means that's a horizontal stretch. So I'm stretching it out 3 times as much. So instead of having within 360 degrees, I have to have it within 1,080 degrees. Luckily, I've set my graph up so that I can do that. Okay, so I'm going to start here and notice that I can get to 540. That's going to be half of it. Okay, and the other half is going to be the negative 540. Okay, so I'm going to start here, and halfway between 0 and 540, I have to reach my maximum, which is 360. Okay. Sorry, my apologies. Halfway between that is halfway between, so it's 270, my fault. Okay. So we're going to reach, it's going to be half of our curve. Isn't that crazy, guys? Okay. And then we're going to do the opposite over here. So we're going to take a look at negative 270. That's going to be my minimum. So notice that it took almost the whole graph, so from negative 540 to 540 to give us one complete cycle, because that is your horizontal stretch by a factor of 3, right? Because remember, it's 1 over K. So it's really stretched 3 times. So that gives you an excellent explanation to why we've always done 1 over the absolute value of k. All right, let's do the last one here, ladies and gentlemen. Okay, the last one says y equals sine x. That still tells us that from 0 to 360, we have 1 complete cycle. However, it's going to reflect the y-axis. So when you reflect the y-axis, I'm going to go from left to right this time. And as I go from here, I've got to go to my maximum up here, and then to get down to my minimum. So I'm going to go maximum here, and back to my axis, and my minimum down here. Okay, remember it reflects the x-axis. So because it reflects the x-axis, it doesn't go, because it's switched around, it's going to go down here and opposite. Okay, it looks very similar, unless there's other transformation. It looks very similar to when you just take it and reflect the x-axis and the y-axis, because it's symmetrical right here, guys. Okay. Okay, so let's just finish that up. Keep going with this. And there you have it, folks. That's k. So let's just summarize what we need to have about k. Okay, so just remember we're dealing with y equals sine kx. Don't forget, watch to factor out k. We've done that for a couple units now, and I still know people have forgotten to factor out k on their unit test. Okay, just remember that if absolute value of k is less than 0, we call that a vertical stretch. Sorry, my fault, horizontal stretch. And that's going to be by a factor of 1 over the absolute value of k. Okay, there's nothing new here, guys, so far. Absolute value of k is greater than 1. We call that a horizontal compression. Okay, and that's by a factor, again, of 1 over the absolute value of k. Okay, just remember, guys, that if k is less than 0 or negative, it reflects the y-axis. Okay, and the new piece of the puzzle that we need to make sure that we understand is that the k changes the period. So just remember that the period equals 360 degrees divided by the absolute value of k. So that's a new tool that we're going to use for this unit. Okay, the rest should be the same. All right, let's deal with our last letter. We've dealt with A, we've dealt with C, we've dealt with K. Now we're going to deal with our last one, which is the D. Okay? So looking at our parent function here, ladies and gentlemen. Our parent function here, we notice that D equals 0. That means there's no translation left or right. Okay? I look at my next one, we notice D equals 60. That means we're going to start by shifting it 60 degrees to the right. Okay. Looking at my third one, notice there's a plus sign. So what does that mean? D must equal negative 120 degrees. So we're going to start 120 degrees to the left. Okay. And I'm going to show you a really neat thing here at the end, guys. Y equals cos x minus 90. Okay, and what that means is you're going to do D equals 90 degrees, but what we're going to find out is there an interesting relationship here. This will actually equal Y, be the same as Y equals the sine x curve. So I told you earlier, that there was a, see if it'll get off that. Told you earlier there was a connection between the two parent functions. This is the connection. So y equals sine x, so sine x equals the cos x minus 90 degrees. But we'll get to that in a little bit. First of all, remember that we're starting with our parent function of cos x. So we're going to start at our maximum, go to our axis, go to our minimum, go to our axis, go to our maximum. Again, there's one cycle, but we're going to continue that on because it's a continuous function, sorry. Okay, so I keep drawing that. Okay, let's sketch that. All right, so there's our parent function. What I want you to notice, guys, is I'm going to put a little dotted line in here. So this dotted line is going to be the box, and it's going to be what we call the starting value. It's going to help you talk about how you start graphing. Okay, so notice I put it my starting value to my end value. Okay, because it gets hard when you do some of the shifting and then you got to shift left, right, up, down. I want you to make sure you know where to start. And that's what D tells us. D tells us our start value. In the second example, ladies and gentlemen, we've got D equals 60. So we're supposed to start here, but that's not our parent function. Our parent function tells us to go 60 degrees to the right. So instead of starting there, I'm going to start right here. Each of these boxes represents 30 degrees. So I'm going to start 60. Okay? So basically I'm shifting over 2 from each one that I'm doing here. So if you notice, I can shift over 2 for each one that I have. Okay? So taking a look, my start is going to be here, ladies and gentlemen. So I'm just shifting the cosec so that it looks like maximum, axis, minimum, axis, maximum. And I'm just going to show you that I always draw this box, and I want you probably to do that for your test as best as you can. And that shows you one cycle, just so you know how to start graphing, because you're going to continue this function on and on because it continues to repeat. Okay. All right, make sure you got arrows at both ends, and we'll just finish this off. There. So notice it's the same as the original parent function. We just shifted it at 60 degrees to the right. Let's take a look at the next one. D, or green one. D equals negative 120. So instead of starting here, I've got to start 120 the other direction. Okay? So that's 30, 60, 90, 120. So I'm starting here. This is where I'm going to start my box. Okay? And if I'm starting at that value, I'm going to have to be at my maximum. And then I'm going to be at my, after I get my maximum, I'm going to be at my axis, and then my minimum, and then my axis, then my maximum, sorry, 1, 2, 3, maximum, then to my axis, 1, 2, 3, then to my minimum, then to my axis. Okay? So taking a look here, I'm going to start here, okay? And I'm going to draw one period or one cycle to show that that's the length of time it takes to do one period. So that's going to be the end of my box right here. Okay, so I can just, luckily you've got an eraser, you can just erase that. Okay, to show you where you've started, where you stopped. And then again, guys, we're just going to continue that on. Okay. All right, 1, 2, 3, 1, 2, 3, 1, 2, 3. So what do you notice here, guys? It's a mirror image of the, you notice it's a mirror image of the one in red, right? Just symmetrical. So that's an example of like those cool tattoos you see. It's pretty neat, eh? All right, taking a look at the last one, ladies and gentlemen. Y equals D plus 90. So normally I'm supposed to start here, but actually I'm going to start, sorry, Normally I'm going to start here, but I got to start 90 degrees away. So I got to start here. Okay? And that means that 90 degrees later I'm going to be here. 90 degrees later I'm going to be here. And then here. Okay? So my one box is going to be right here. Okay, because I'm going to start here. I'm going to go down and come back up. Okay. So what do I notice here, guys? And just 1 second. I apologize. What did I do wrong here? I apologize. Let me back that up for a second. Sorry, guys. Just 1 second. I think I've got too many graphs on here. Okay, so let me fix this for a second, okay? I forgot to come back up to my maximum here. So just back up the truck here, sorry. Here's where we started. So we started our max, axis, min, axis. I just forgot to come up to my max. That's the mistake I made. So I come up to my axis, which is right here. So there's where my one box is. Sorry, guys. I want to make sure I've got these colors right. Okay, so I start here, I go down, and I come back up. Okay, so notice that looks like the Coase curve the way it is. But if I extend it, ladies and gentlemen, down here towards the left, notice what happens. It looks exactly now like I started where? It looks like I started at the sine, like the sine curve at the axis instead of at my maximum. Okay, so this is in fact what we actually get. Okay, so when you take cos x and you transform it, oopsie, 90 degrees, you take it and you transform it 90 degrees to the right, you're going to get sine x. So from cos x, shift it 90 degrees, you get sine x. Okay? That's what I wanted to prove right there. All right, let's finish this up, guys. I know it's a long lesson, but lots of things to go over here. So just remember, guys, that if D is greater than 0, it's a horizontal translation. Okay, and it's going to be absolute value of D degrees, right? Because we're now dealing with degrees. Just 1 second, folks. I've got a phone call here. Let me just pause this video for a sec. I'll be right there. Hey guys, I'm back. Sorry about that. It was a phone call. I just noticed there's a little typo on my handout. Maybe yours is fixed, but mine has a property full. It should be 4, so just make sure you got that fixed up there. So I apologize for that delay. Let's keep finishing on here. Okay, so if D is greater than 0, we got a horizontal translation, degrees to the right. If D is less than 0, again, horizontal translation to the left. That should be nothing new, but we're going degrees this time. Okay, and the new thing, ladies and gentlemen, is that D is our start value. So D is the starting value. Tells us where to start drawing our box. Okay, so that's the key part that we need. So notice that with each letter we had something new. Okay, we're going to summarize that all on this last page, which is what I want you to know for your test. Okay, stay with me. I know we can do this. So in summary, and make sure you study for your test. I will provide you the transformation formulas like I have done in the last previous tests. Just remember, what does A, K, D, and C do? Because we're going to be mixing it all together. Okay? So let me just quickly write this out. If A is less than 0, we know it reflects x-axis. Okay? If the absolute value of A is greater than 0, it's a vertical stretch. Okay, if the absolute value of A is less than 1, we know we've got a vertical compression. Okay, so that's A. The other letter that causes us some confusion as well is the K. So if K is less than 0, it reflects the y-axis. Okay, if the absolute value of K is greater than 0, you're going to have a horizontal compression. Okay, don't forget it's by 1 over K, absolute value of K, right? Okay, if K, absolute value of K is less than 1, we call that a horizontal stretch. Again, by, don't forget, 1 over the absolute value of K. Trying to make that fit in there. All right. Dealing with our other letters, so those deal with our stretches and compressions and reflections. The other letters that deal with our translations are D and C. So if D is greater than 0, i.e. it looks like in your brackets x minus D, we know that's a horizontal translation to the right. Okay, and remember this unit we're going degrees, okay? Okay, x is less than, or sorry, D is less than 0. What does that look like in our bracket? It looks like x plus D. And that means we're going to have a horizontal translation left. Okay. And the last letter that's going to help us with some translation and shifting is if C is greater than 0, we're going to have a vertical translation up. Remember that shifts the axis up as well. And if C is less than 0, we've got a vertical translation down. Okay. If you look in your textbook on page 378, it asks you to summarize and reflect on what we've learned. I'll just help you out with this, folks. You should remember these things right by now. So the period equals 360 degrees divided by the absolute value of K. Okay, the equation of the axis, how do we find that? Y equals C. Okay, S says to ask you the amplitude. The amplitude equals the absolute value of A. To find the maximum, there's two things that affect that. The axis, so it's going to be C, plus the amplitude. Okay, and to find your minimum, it's going to be the axis minus the absolute value of your amplitude. If we know the max and we know the min, then remember that the range is such that x belongs to a set of real numbers such that it's the minimum, has to be less than or equal to y, less than or equal to the max. Okay, but if we sub in what our min and our max are, we can simplify it even better so that y belongs to a set of real numbers such that C minus the absolute value of A, that's my minimum from the left side, is greater than or less than or equal to y, which is less than or equal to C plus the absolute value of A. All right. Just finishing up, ladies and gentlemen, your two base functions or parent functions, there's 5 basic parts. So if we take a look at the first one, if we go y equals sine x, you start at your origin, okay? You know it's going to take 360 degrees to complete. At 180, you're coming back to the start at the axis, midway through you're at the axis, and at the last point you're back to the axis. Okay, so if we put a scale of 1 on here, and this being -1, so you're going to start at your axis, go up to your max, okay, down to your minimum, and back up to your axis. And I'll just show one cycle there to help you. Okay, so just remember, the key for this one is you go axis, max, axis, min, and then back to your axis. All right, that's the key for sine theta or sine x. Okay, y equals cos x. You'll also see it cos theta as well. Okay, this is a little different. Again, if we label 1 and -1, we're going to start at our max, which means in 360 degrees we're going to end at our max. Okay, halfway through we need to be at our minimum, and then we hit our axes in between. Okay. Okay, so the keys to remember for this one is you start at your max, go to your axis, go to your min, axis, and back to your max. Okay? And again, folks, these continue as we go left and as we go right. That was perfect timing, ladies and gentlemen. Try some homework here, page 379, numbers 1 to 3. Have a great day. I know that was a long lesson, but hopefully it was informative and it got you a lot of understanding.